All right. Thank you so much, New York. Tuesday night, it's beautiful out, and yet you come and hang out. We appreciate it. Hopefully we have an exciting event planned for you tonight. First off, some thanks to the sponsors and a couple of community announcements. First up, Sysdig is very pleased to sponsor tonight's event. In case you don't know who Sysdig is a container intelligence platform. Sysdig provides a suite of open source tools for container troubleshooting, forensics, and runtime security. Sysdig also provides a commercial offering SaaS and on-prem for container monitoring and observability, as well as container runtime security. If you have questions, Derek, right over there, the gentleman in the nice blazer, will be more than happy to chat with you. Next up, my name's Ariel. I am from a company called Stackpoint Cloud. We make it really easy for you to deploy and manage a bunch of cloud-native tooling to Kubernetes clusters and all the leading cloud provider. And in December, we announced a partnership with Cloudflare. Has anybody heard of Cloudflare Warp? Yes? So, if you've used it, if you've played with it, if you're interested in potentially being a partner with us as we try to get this production ready, we want to bleed together. That's probably not the best word. Should be an email. And let's figure out something. So open to that. Container Days, New York City. It's coming April 3rd. Look for an email. I'm working with the Docker NYC folks, Jesse over there, and a couple of different folks from Google and Packet to organize this stuff. So if you are interested in it, go ahead and register. It's going to be $50. It's Tuesday. It's going to be an all-day event, single track. And if you are an end user and interested in presenting, again, shoot me an email. We'd love to fit you in. All right, BounceX, Danny. BounceX, thank you so much for hosting us and the great sandwiches. They are hiring, and Danny's gonna tell us a little bit about that.
Sure. Hi, thank you so much for coming out tonight. We're so excited that you're all here. Like you said, we are actually hiring, so if you want to talk to us, we're hiring for our data, our identity, our SREs, infrastructure groups, as well as product engineering. Come talk to me after the events. You can find me just hanging around in the back. Some general housekeeping, we have food over that way. Bathrooms are to the back and to the left. What's that? No more food. No more food, sorry about that. But again, bathrooms are to the back and to the left. Thank you so much.
All right, thank you. Home team. Sime, did you want to come up? We have announcements. This is Sime leads the Oracle New York City users group.
New York Oracle users group. We also have a meetup, NYOUG meetup. We have a session coming up, an event coming up on March 6th. It's about a combined meeting with microservices, and our sponsor is Oracle. New York Oracle user group is totally an independent group. And also in this event, we're going to have an API first microservice development on Kubernetes. And the other thing that I wanted to, the event is going to take place at the Oracle headquarters, 120 Park Avenue. You can find out at the NYOUG meetup all the detailed information, March 6th. And then there's also another event coming up, March 8th, at Jacob Javits Center. It's an Oracle code, and it basically includes Kubernetes, microservices, Dockers, all different types of technologies, as well as Oracle technologies. So come and join us on March 6th. It starts at 6 p.m. Until 9 p.m. Okay?
Awesome.
Thank you.
Any more community announcements? Anything cool happening? All right. On to the speakers. Sean Bauer. Did he come? No. All right. So we're gonna cross our fingers. I think he was coming down from upstate. Hopefully he'll make it. He's been working at the Times as a Docker captain and kind of helping him move everything over to Google Cloud Platform and Kubernetes over there, having previously done that at Cornell. Martin from Namely is going to get the first pass. He is a principal software engineer there, helping them build out their distributed systems architecture. And previously he worked at Amazon and Google doing all kinds of distributed stuff. Yeah, and he's going to tell us about all the cool stuff that they are doing it, namely with bleeding edge technology. And then we have Adhita from Stonybrook University. He's going to give us a brief talk on some of the research that they are doing there on machine learning and Kubernetes with Kubeflow. Very happy to have him. Both these guys, first talks, so be gentle with them. And Adhita also was a diversity scholar winner for KubeCon, so we're very happy to welcome him here for that. Thank you much. I'm going to get out of their way. Martin? Here you go.
Oh, nice. Hello? Cool, I can hear you. Cool. Okay, so let's bring this on. I lost my presenter view. Okay, sorry. Sneak preview. Not sure. I don't know why it's showing the. Oh, I think Chrome is over. No, Chrome was doing some Chrome difficulties. Okay. Sorry, technical difficulties. All right. Cool. Okay, sorry for that. Hey everyone, I'm Martin Kess. I'm a principal software engineer at Namely. And so in this talk, we're going to talk about our current strategy for building services and sort of deconstructing our old legacy software, and some of the techniques we've used to do that. First, a little bit of background about Namely. So Namely is about 6 years old. It actually just passed its 6th birthday in January. Based out of New York City, we're a startup, but we've raised about $150 million. 100 engineers, we're growing really quickly. We're really, New York City's our engineering base. And we do 4 things primarily. We have a HCM, which is human capital management. And you can think of it like a social media website for employees. And so you can see here's a screenshot, and there's like a wall. Employees can enroll in benefits, they can request time off, they can see who reports to who. It's a way for employees within a company to interact with each other, both through process and just socially. We also do benefits, and so a lot of what goes into benefits is integrating with insurance providers, 401k providers, and helping companies, especially like small and mid-sized companies, offer these benefits to their employees. And then finally, we have an analytics offering that lets us like you want to say how much is my payroll for this year, or you want to, looking forward, you want to say something like, hey, if I open an office in San Francisco versus Austin and I want to hire 50 engineers, how much is that going to cost me? Like, let me run some scenarios. So we process $8 billion in payroll per year. I'm not sure when this is, like what the date of this was, like last year. And some people I've met at these meetups have been customers of ours. So thank you very much for using our product. And we've got really exciting things coming up over the next couple of years. So to give you a little bit of background on Namely, and this talk is going to start out sort of at a high level and then dive into specifics of how we're using Kubernetes and various technology around it. In terms of software, it's arranged around 2 monoliths. So unlike most companies, we have 2 monoliths instead of just one. HCM, which is again this front-end thing, is a standard sort of Rails app. And within it, it has all of these different concepts of things like what's a team, what is a company, what is an employee, what are salaries. And this is stored in in a database using Active Record. We also have payroll and benefits. And this also has ideas of of common concepts, like what's an employee, what is pay, what are subsidiaries. And so these concepts overlap. There's unique concepts, like what's a division, so different groupings, and because they were designed for different goals, right? So the goal of payroll and benefits, like the goal of payroll is to pay you, right? Make sure your paycheck gets cut. We withhold taxes to the right and pay the right organizations. The goals of HCM are to provide more of like a social experience on a website. But over time, these concepts have sort of diverged. There's duplicate data. And so we wrote a bunch of magic to kind of stitch this together. We grab data from both databases, we try to reconcile it. When something's blank in one, not in the other, we stitch it together. Don't worry, this is history. We're doing more interesting stuff now. But just for context. And then analytics is just basically a bunch of SQL scripts that are diving into these databases, pulling things out. And this causes a lot of problems, right? This causes like what happens when data doesn't agree? What happens when someone changes a SQL schema, right? And then suddenly analytics breaks or something on the other side of the system breaks. And so we needed a way to kind of manage this complexity. And what we came up with is this idea of verticals. And so the idea is that we, like, rather than arranging our sort of company and our software around, technology, right? Like Ruby on Rails or, whatever these like massive servers are, we were arranging them around concepts. And this is sort of less accurate. It's more of a graph than a, single independent things, where we have a front end that kind of stitches things together. And your front end might be your web browser. It might be something that generates a file. So we generate these notcha files that is how you actually, like this file you send to banks to withhold money to pay the right people. Or it might be an iOS app. And these verticals are now services or microservices that manage, like, what is the concept of an employee? What's the concept of a company? And then so these like sort of foundational services build these core concepts, and higher level services will stitch them together in terms of like grouping people. We also feed all of this into an event stream, which is Kafka. And this goes into our reporting engine. So now reporting can run in a background job. Like one of the problems we've run into quite a bit recently has been someone runs a big report and it brings down the database, the production-facing database, because it's locks some table accidentally. And so now we have a nice way to things can emit events, and our reports can kind of be handled asynchronously with read replicas and not affect production. And this is we're in this transition phase of this, right? So we sort of started off with this last slide, we're moving towards this, and we're somewhere in the middle. And so as we go to this service-oriented architecture, this microservice-oriented architecture, the first kind of question we asked was why do we want to do services? Why is this a problem? And what does it mean for something to be a service? And we came up with these 4 points of service development. Of that first thing, anything we do should add value to the business, and we should understand why it adds value to the business and how to explain that. But the biggest thing is that it should be the source of truth for data and functionality. And so I think a lot of places that go into microservices or services, you end up, it's very easy to accidentally build a distributed monolith, right? Where you, services doesn't mean you've just got a bunch of Docker containers running in random places, all talking to the same database. It's you want to have this idea of a bounded context, right? You want to have your database and something that's the authority of those tables, the one thing that reads and writes those, and that's your service. And through this, we want to prevent coupling, right? We don't want employee to be existing across 6 different things. We don't want to have to deploy these 4 services in this exact order every time. We want to just have these independent things that own a concept, like the concept of an employee, the concept of a company, and be that source of truth for that, and be deployable. And finally, we wanted, a service has to offer uptime. One of the things you really quickly run into with services is you have 10, 20, 50, 100 of these services, is that you need to know when things are available, what's broken, when things are broken. You need to be able to make sort of performance guarantees at the very front end. Like I want to say, I want to go to namely.com and load it in 200 milliseconds. And you need to sort of be able to work backwards from how long if your services are taking longer than 200 milliseconds, your front end can't load in less than 200 milliseconds. And so part of being a service is saying like, how fast am I responsible for being? And if I break that, someone should get alerted, someone should be aware. And services are hard, right? Like one of the nice things about a monolith is you check it out from GitHub, you run it or you build it, and you're going, right? Like something crashes, great, you get a nice stack trace. You need logs, you can read the logs from top to bottom. You can't do that with a distributed system. Especially when you have like multiple databases, right? So this idea of owning your data sort of implies that there's multiple databases. So you can't have a transaction that spans 3 different databases, right? So this leads to consistency problems. Like if something's updated in one place, how do you make sure that gets propagated? Our answer to that is using a message queue. So Kafka sort of lets us have this idea of eventual consistency, where you publish a message to your message queue, your employee service is the source of truth, saying like, hey, this employee got updated. Maybe they're like, their boss changed or something like that. They can publish a message and other systems can incorporate that change downstream. Deployments are hard, right? Like rolling out one thing is sort of easy, right? You roll it out somewhere, you write a bash script that runs it, great, it's running. But now you've got 50 services. How do they talk to each other? One dependency doesn't come up, your service comes up, dependency crashes. How do you coordinate 50 deployments with your team of engineers without everyone having to talk to everyone constantly? Right? If you have 100 services and everyone needs to talk to each other, right, you'll never roll anything out because everyone will be arguing constantly. Development's hard for the same reasons that deployments are hard, right? You have so many services that you're running, you can't, how do you bring them all up on your laptop? And what happens when you can't, right? It might make sense, like maybe it's feasible to run 10 Docker containers on your MacBook Pro, 100, 1,000, 10,000, right? You need ways to deal with this. And to be fair, that's something monoliths eventually hit too. And finally, like debugging's hard, right? So the nice thing with monolith, your logs are going to one place, you can sort of like look at that thread ID, you can trace that through the logs, but suddenly your logs are in a whole bunch of different places. So you need a way to kind of reconcile this. And one of the things is that I think you sort of have to build this very deliberately. Like I feel like with a monolith, one of the nice things is that you can write your code, it runs, it crashes, okay, you fix the bug, runs, it crashes, you fix the bug, and then eventually it works, right? I mean, you sort of via gradient descent figured out how to make your program work. But you can sort of, and that's not an ideal way to do development, but with a distributed system, you can't really do that, right? Because you're just you can sort of introduce more and more problems as you fix bugs without having an overall holistic view of the system. So in pictures though, what I'm talking about, this is what a service looks like, right? You have an API, and this is the way that the outside world talks to you. You have some business logic, and that's just like does what your service does, right? That has this model of an employee, and it translates your API requests into some state, into maybe further API requests, etc. Maybe it has some storage, you don't know. But again, only this service is talking about storage. You don't have many different things talking to it. And then you need to export, like for this reason of visibility, you need to export metrics, your logs, APM, so a bunch of companies offer just like performance metrics, etc. And then so when you have a bunch of these, you end up in a state like this. Or you have a bunch of these services, they're all talking to each other, the business logic is talking to each other all through the APIs. They own their domains, you have an acyclic graph of your services, and they're each responsible for whatever that service is responsible, right? So this might be like a company service, and this might be like some front-end wrapping service that kind of reconciles your state. But all of this, if this is a company service, all of your state for a company, like this owns that domain, and has to provide an API that lets people access that state and manipulate that state. And so as we approach this, like our goal of building our infrastructure is to reduce complexity, right? This is very, like I've described, a very complicated world. Whereas with Rails, it's nice to check out one application, you type, Rails serve, and you're up and running, or whatever system you're using. And so as part of the, driving a lot of the infrastructure efforts, we're trying to strip away the complexity of building services so that to the extent possible, you can just focus on this green box. Like the goal is you want to write a service about employees. You don't want to have to think about logging. You don't want to have to think about metrics. You don't want to think about how do I roll this out. You don't want to think about what's my API, what database do I use, how do I even get a database. You just want to sort of think like, hey, I want to write something with employees, and this should be as easy and reliable as anything else. We talk about infrastructure as reliable as running water, right? Like you think if you turn on a tap, a lot goes into that, but the water comes out 9 times out of 10, or 99 times out of 100, hopefully. And then the other thing is, as we grow, we also, a reason to tackle this, to manage this complexity and reduce this complexity is that as we grow as an organization, so this x-axis here can be the number of features that we have, the number of employees that we have, anything that we're growing is a successful business, right? The number of customers that we have. We don't want to have to sort of scale our costs up here, right? I mean, because you can imagine if you're here and you double your number of customers and suddenly you're like way up, above, out on the roof. But it's very easy if you sort of like, if you don't have a sort of holistic view to scale linearly or worse, and you can hit a stopping point. So now we're going to sort of start to dive in. Oh, sorry, institutionalized toil, right? This is the little dive in. And so a lot of our philosophy has been like fighting against institutionalized toil. And so what is toil? Toil is just things that you have to sort of do manually, that you have to, like cognitive load is one, where, hey, I want to write a service. How do I log? Where do my logs go? How do I get metrics? Where do my metrics go? How do I roll this out? How do I build this? Like, how do my services talk to each other? And as someone who wants to like build a model, a concept of an employee or some new domain, you don't want to have to spend days just figuring all this stuff out that you're going to have to figure out every time. So we're standardizing tools around this. We want automation, right? You want a database. Well, you should say like, give me a database, and you magically have a database. And all this tooling that goes around that. And then we want to reduce boilerplate, right? So things like authentication. Why should every service have to think about authentication? I mean, you should care about authentication, meaning like your request should come from someone who is who they say they are, but you shouldn't have to, every service can't figure out what authentication is because then you're just spending all this time scaling, super linearly. And so also like authorization. Are people allowed to do this thing? Well, we should have a very straightforward way to do that. You shouldn't have to think too much about how to figure that out. And especially for us, and I think most businesses have this, but we deal with very sensitive data. So things like people's social security numbers, their salaries, we pay people, or we don't pay people, but we enable people to be paid. And so we have to be very strict controls around PII. And PII is really hard to work with because you get an object back and you're like, oh, what happened? I threw an exception because some null pointer. And darn, that object had a social security number. Now you get a social security number in your logs. Right? And that can be hard because that might not be, it might make sense not to throw a top level, it might not make sense, okay, we know an employee is PII, but you might have some subsidiary and your brain, you're just thinking, okay, what's a subsidiary? The company's name's not PII, but it happens to have some pointer to an employee. And it's impossible, you can't police this with policy, right? You have to sort of police it with technology. And again, so as an application developer, the less time you spend thinking about these things, the more time you can spend thinking about what is my domain model, right? What does an employee look like? How do people interact with an employee? What does the company look like? And so now I'm going to dive into the technology part of this. So we're running on Kubernetes in AWS on Docker, not crazy. We're using Istio, which is a really neat service mesh. Very, very powerful. I think this is probably the neatest technology I've seen in years. gRPC is most of our services are using gRPC. We're rolling out Spinnaker, which is a really neat piece of technology that Netflix open sourced for doing continuous delivery. Datadog, New Relic, Logsy, Bugsnag are all ways to capture aspects of metrics, monitoring, et cetera, APM. Jaeger is a very cool technology for doing open tracing, and so it lets you trace, you have a request going through the system. So again, one of the things that's hard with a distributed system over a monolith is that where did my request go? This request took 10 seconds, why? Right? Easier to say with a monolith, hard when it goes, that request went through 15 different services. Now you can sort of say why. And then as I mentioned before, our message queue is Kafka. So gRPC. gRPC is a really, really cool, very powerful framework. Most of our services use it, and long-term, hopefully all of our services are going to use it. And what you do is you write an interface for a service. You can think of it like, if you've ever written C, like a .h file, or if you've written any other language, an interface, right? And this is the way that services talk to each other. And one of the really hard things you find with distributed systems is that as you have these servers and these clients, updating, you want to be able to do independent deployment, but if you want to change your service interface, you don't want to have to coordinate updates with all your clients. And then how do you even do that, right? If you update your clients, how do you do that without updating the servers? So the schema of Protos and gRPC lets you manage this in a nice way. And one of the things we do, first sort of bit of technology, is we keep all of our protocol buffers, like all of these IDLs, in a single repo, so that anyone who needs to be either a server or a client can just check out the whole repo and access the latest, and then they just do a git submodule update when when they want to get the latest and greatest. And then it's the responsibility of these service developers to maintain backwards compatibility. And so here's an example of a very simple protocol buffer defining the fake people. So you can see, so here you're defining actual methods. This is a create person method that takes a create person request and returns a create person response. And these are the various message types. So here's a create person request, takes a person as one of its objects, and a person is their name. It just has a sort of flavor of what the syntax looks like. And so what you do with gRPC is you compile this into your language. So let's say you're writing a Ruby service. You will compile this, and the gRPC compiler will generate a Ruby class for you that you can now use to call this. If you're generating a client, it'll let you call the server, and it handles all the networking for you. If you're writing a server, it'll generate the interface for your server in whatever programming language you're using, and then you implement that, and it again handles all the startup, tear down, all the networking. You just basically implement a void create person that takes a create person request and returns a create person response. So now our sort of service looks a little bit more concrete. API changed into gRPC API. Pretty crazy. And now, the web doesn't speak gRPC, right? The web speaks HTTP. So Google released this really nice plugin called gRPC Gateway. And actually, I just learned that Istio even supports this natively. But what you can do is you can annotate your proto with URIs and say, hey, I'm going to map this RPC to this HTTP endpoint. And this gRPC Gateway project will just compile this into a Golang server that is an HTTP server and a gRPC client. So it gets an HTTP request based on these rules. Like it knows here that first name is actually that first name field in this proto. I made a mistake. That should be name. But so name is that name field in that proto. Automatically, through only writing this code, you get an HTTP to gRPC translation layer for free. And this is like eliminating toil. Like, how do I do RPCs? Okay, you write a gRPC service. How do I do HTTP? Add these annotations, run a compile script. Great, you've got an HTTP server for 10 minutes of work. And so now, here's what our service looks like, right? So we have our HTTP to gRPC translation. And again, that's the only thing you write. Like you just write those annotations and everything else happens for you automatically. HTTP call comes in, gRPC turns into a gRPC call, goes into your magic. And other services can call gRPC directly still. This is just mostly useful for the front end that maybe doesn't have a good gRPC client. And then, so like I mentioned, we have this really, really cool technology that Google released called Istio. And Istio is a service mesh. And so it sort of sits on top of your cluster and gives you a lot of really powerful technology to eliminate more of this toil. So one of the great things it does is it lets you export metrics for free. So you don't even have now you're like, okay, well, we want to know how many requests did I get? So everyone's writing that boilerplate, request.count, increment 1. And you get this for free on Ingress, right? This little magic, zero code written by the person. How long did my request take? What requests are failing? What status code did it return? Et cetera, et cetera. One thing you'll quickly learn with distributed systems is you have to do retries. You get a deadline exceeded. Okay, we'll write this retry logic. And then the Google S3 book says, well, actually, you should do exponential backoff with randomized exponential backoff. So people implement that. People implement that with bugs. People just, if you don't have in the library, there's some more toil, right? You have to write another client that does this thing, and you might have bugs in it. So Istio does this for you. The client, your Ruby code, your C# code makes an RPC, and it thinks it's making one long RPC. The service mesh, this sort of hidden layer that the app developer doesn't see, is actually making retries. It does circuit breakers. So circuit breakers are a really powerful concept where, let's say you're getting a 500 error every time you hit this endpoint. Don't make that request. Let's let that service sort of heal itself, and we'll just return a 500 automatically. So a lot of people, you implement that in whatever library. You make, hey, I've retried 10 times, I've got 10 errors. I'm just going to cool down and not make requests for a while and just return an error automatically. Istio handles this for you. Validation of authentication headers. So again, in authentication, basically what we do is we inject a header that says, this is the user making this request, and you'll never get the request unless the user's authenticated. And you just trust that header because it's inside the network. And the way we do this is with the JSON Web Token. And so what this will let us do is authenticate that token. Is it signed properly? Is it expired? App developer doesn't care. They don't write any code. And they have this idea, so this Istio mixer is one of the pieces of Istio, and it lets you write custom handlers. So if you have your own totally custom use case, right? You want to make sure that it has this HTTP header or this gRPC header. You can write a little handler for doing that. And one of the powerful things about Istio is that it is protocol aware. So you can actually, it understands gRPC. So you can actually inspect the values of gRPC. So with our name service, if we only want to be able to create people whose name is Mary, you can enforce that at the Istio level, and your service will never get a request from anyone whose name is not Mary. And you can inject open tracing headers. So this is what Jaeger is. So requests come in, they get those headers injected, and go. There's no need for people to write custom code to check that. And one of the powerful features I'll talk about later is the smart traffic shaping. So you can sort of selectively route traffic. And you can say like, I've got service version 1, but I want to route like 1% of my traffic to version 2. Or if you have this header and this field value in the packet is this, direct it to this service instead. And I'm going to talk a little bit later about how we use that for local development. So now what does our service look like? So this stuff's all the same, but now this Envoy sidecar gets injected. And it's just, at the heart, it's like a pass-through layer. It gets the request, it applies some rules, and then forwards it to this gRPC API. And for free, you get a bunch of metrics logging APM. Services will still want to log and do metrics on their own, but this gives you a lot of the boilerplate metrics, right? You want to log the interesting metrics. You don't want to log number of requests you got, how long each request took, right? How many times you retried. Like this stuff is all mechanical, boring. Don't waste your time writing, because Istio will do it for you. And then, okay, so great. So now we've got really nice metrics. We know if our software's running. We know if it's working. But how do we like roll out our software? And again, we want this to be super easy. So people build Docker containers. Right? Namely's built on Docker containers. And we're just rolling out actually now Spinnaker, which is this great CI/CD tool that lets you build these pipelines. And so the idea is that we want to integrate our code early enough. And you have 50 different services. Some of them are going to break. Some of them are going to have bugs. We want to catch those as soon as we can. And so the idea is like we should roll out as frequently as you can. Rollout should be painless as possible. And at the very least, let's get our code into an integration or staging environment, quickly. Like don't have a 5,000 line change sitting on your laptop and then roll it out and be surprised when the world breaks, right? Every time you submit to master, Jenkins picks it up, builds it. 2 minutes later, it's in our integration cluster. You click a button, it's in our staging cluster. You click a button, it's in production. Easy ways to do rollbacks, hot fixes as well. So this is all sort of part of what we've done. And we've even reduced toil here further. One of the things you have to do is like define your workflow. And this is like a very, it's hard. Like there's a lot of choice here. You basically define a graph. Like do these end steps with these end roles, or these end roles. So we made this like pipeline YAML file that lets us very simply define, like we've taken an opinionated view of what a rollout looks like, right? It goes to integration, then staging, then production. There's a step between integration and staging, and there's a step between staging and production where someone clicks a button just to say like, yes, manual verification, I trust this. So developers can just write a little YAML file that sort of defines like what do you want to roll out. And our tooling, we're building a webhook right now that will automatically create a pipeline from this file. Commit to GitHub, create your pipeline. Update it, update your pipeline. So reducing toil. Right now you don't have to think. You write this little file and you get this. And then finally, okay, so we're doing all this stuff in clusters. Like I said, you have 50 services. It's really hard to start them up. It's really hard to run them all on your laptops. Like these are not very powerful laptops. Apple's got to give us a quad-core 13-inch laptop at some point. So we want to make it easy. And so this is one of our current projects that we're working on. This really neat company, this tiny company called Telepresence, called DataWire, that's based out of Boston, released this tool called, I didn't even mention them here, I'm sorry. They're really awesome, DataWire. But they released this tool called Telepresence, and what it does is it lets you put a two-way network proxy in the cluster. So you're running a Docker container on your laptop, it runs a fake version of your service in your cluster, right, in AWS. Traffic comes in, and it says, well, actually, I'm just a fake service. Let's forward that request to the Docker container running on your laptop with a debugger, with, like, it's actually running here with, like, hot reloads, because every time you save code. And likewise, when you make a request out to one of these 50 dependent services, it goes right to the cluster, and then it goes to the actual service. So you can work on what you need while being very, very tightly integrated with the rest of the cluster. But we've got a trick. We combine this with Istio to make a really neat tool. And the idea is this Istio routing rules. So remember I said you can actually like selectively route traffic based on what is in contents of the message, right? And so what we do is we built a wrapper around Telepresence that says, hey, if this user who's debugging has this request, actually send the request to their laptop instead of to the service in the cluster. So this means a bunch of developers can be developing the same service or different services together. And as soon as you start developing a service, you start getting traffic from the cluster as yourself, right? And so like a lot of the people, the background at Namely, it's a lot of web development, a lot of Rails developers, and so like people are very comfortable working on, say, a backend feature, but they want to click through the GUI and see it work. So what do? You run this tool with your backend Docker container, say the account service. And now you go to the website, like you go to testcompany.namely.com, which is like a testing account. You click through, you're hitting the cluster service, cluster service, cluster service, you get to your feature, and magically your traffic, and only your traffic, is routed back to the cluster, back to the one running on your laptop. If it crashes, it doesn't affect anyone. If it crashes and you rage quit and go home, eventually it sort of heals itself and everything goes back. And so this sort of makes local development easy, right? You think of what does your development loop look like? Okay, so I check out my code, I write some, I load up my editor, I write some code, I debug it, I'm like, okay, I'm happy it works, submit it to master, Jenkins picks it up, Spinnaker deploys it to our integration cluster, and like within 5 minutes, it's, B prime has replaced this B service because of all this tooling that we built. And this is sort of like really tightening the loop, right? Like a lot of what we're trying to do is like tighten the loop. And you make a new service and you get all this as well, but plus like you've got all your metrics. The only thing you really have to do is like build a templatized dashboard. Yeah, and so really what I'm trying to say is this, like, so above all else, you want to provide value to the business, and we're trying to be very aware of that. Like, we're trying to make sure that what we're doing, I love technology, and I could go technology for technology's sake is awesome, but I want to make sure that, the company is really trying to provide value and be forward thinking about how we're, trying to grow our company and serve our customers. Payroll is a very important thing, right? You miss a payday, that has real consequences on people, that is really, and so like we have to take that very, very seriously. Fortunately, there's a lot of, we haven't missed a payday, but it's a, it's a real sword of Damocles hanging above us. We have to understand what a service is, right? So it's easy to say like a service is Docker containers running in Kubernetes, right? But you can very easily build a distributed monolith, right? We have a bunch of Docker containers that have a very like defined order of how they start up, and you've just made it yourself, you've given yourself all the weaknesses of services, all those difficult things of services, combined with all of the worst parts of a monolith. And so you've just dug yourself into a big hole. And your APIs are important. Like we spend a lot of time thinking about those APIs, because APIs are hard to change. APIs are sort of your contract with the world. And if your API doesn't provide what your clients need, either your clients being like into other services or like your customers, you're in for a bad time. And then the way we've sort of framed this has been like fighting institutionalized toil, right? Let's have the computers serve us. We don't want to serve the computers. We don't want to have to pull levers. We don't want to run scripts or like click through GUIs, right? To the extent possible. I mean, obviously we haven't automated everything. We haven't sort of reduced all this toil, but we're doing our best, and that's my talk. Thank you. If you have
Questions?
I really like the CI/CD pipeline you had going. Is that DEC or what tool is that?
Oh, this is a Spinnaker.
Oh, Spinnaker.
Yeah.
Okay.
And so.
So that enabled you to build the UI, or?
No, that comes with UI. So
Okay.
It comes with the UI. And what happens is Jenkins basically listens for code, like commits to GitHub, to our master branch, and then it builds them, and then Spinnaker listens for that like build artifact from Jenkins. Jenkins being like just runs like Docker build, right? So Spinnaker then listens for that, and then it runs into this pipeline that's defined for that project, right? So each of our services is a GitHub repo. When that GitHub repo is, when that's built, Spinnaker just picks it up and runs it through this pipeline. And then like I was talking about, this pipeline YAML file lets us sort of automatically create this pipeline, given like a sort of opinionated view of what this should look like. So Spinnaker is super flexible. Oh, and you can have it too. I learned it's open source. So you go to namely/k-pipeliner on GitHub. It's open source.
So you're saying Spinnaker not only, deploys whatever Jenkins builds, but it also has the UI, and then, from staging to prod,
So it has
Does it do everything?
Yeah, and it does everything. So even integration.
Okay.
So integrations environment's the first one. Stagings are like, we're pretty sure this is ready for prod, and prod is prod, right? And so Spinnaker actually understands Kubernetes. So it'll tell you like what pods, it understands a Kubernetes deployment, and you just configure it saying like, point to this cluster, give it the address of your cluster, run these commands for this workflow. And a workflow is like a series of steps, saying like, run a rake migrate, run a Docker, or run a kube control up kind of thing.
So would you say this is like Circle CI or?
Similar, yeah, very, very similar.
Okay.
We found it more flexible for our needs, but Circle CI is another one. You can use Jenkins for this sort of thing.
I really enjoyed the talk. It was great. I just wanted to ask, I've been to talks about containers and services and whatnot. One talk, I remember specifically, the guy said, if you can't run your development environment on an airplane, then you're doing it wrong. And I don't mean like, today we have Wi-Fi on everything. Yeah. And I was just wondering if you would refute that, or what you say to that. And I definitely appreciate the local kind of low latency environment without having to reach out to the network.
Yeah, and I mean, to an extent you can. Like, I mean, it's not like you lose your internet and you're down. A lot of this is like, hey, I want to test, there's a lot of moving parts. You know, you can't bring up the whole system on your laptop eventually, right? You know, like if you work at Google, you can't bring up all Google on your laptop. Because eventually, you know, there's a scaling limit to that. But you can still like run your code locally. You can still stub out endpoints. So you have some power to develop, but a lot of it is built around having, you know, access to this cluster. Your tests will still work, right?
Do you keep Istio running in production? And also along those lines, what other policies are you thinking of using when you're thinking about Istio?
Sorry, I missed the first part of your question.
Do you keep Istio running in production?
As of today, yes. So we're rolling it out. We've been rolling it out for the past quarter. So as of today, it's running to some of our production traffic.
I'm concerned about overheads or performance hits of things that the Istio layer is doing for you.
So Istio is not, like, so Istio wraps this proxy from Lyft called Envoys. We did a bunch of benchmarking. We actually, for strangely, saw better performance with Istio. We're not entirely sure why. In that, you know, it's more stuff and it's a little bit faster, but it's been comparable, and so we haven't had problems. We're still in the actively load testing, and like we're in the early phases of rolling this into production. And your second part was like, what other things are we doing with this, right? So the first things that we're doing with this are this sort of these well, I guess local development is the first thing. A lot of this like authentication at the edge, right? So our idea of like, let's inject authentication headers and let's validate them in front of each service. And so as you spin up a new service, you get authentication for free. You'll never receive an unauthenticated request. Unless you explicitly register yourself as saying like, yes, this service explicitly handles unauthenticated requests, like your login page, for example. The other things is authorization, PII at the edge. Like we've got this really neat idea of how do we, maybe we can like automatically strip out PII. You know, like your service, if it doesn't really care about social security numbers, like it should never have a social security number. Because all this, you know, all this chance of doing this, you should never log a social security number. And so now this sort of lets other teams apply policy, and as a developer, I don't care. I get an object, like I get an employee with social security number and lots of PII object, I can log it. And you know, the system will just strip out anything you're not allowed to log. Or like you view things, you know, you're debugging a client. One of the things we'd really like to do is, let's say you're impersonating a client to debug their issues. Wouldn't it be nice if you could very selectively say what fields you're allowed to see of that client? Or like, let's say they're saying like, hey, your first name is the only thing you're allowed to see. So let's, you know, like, let's just never ever send that data to the front end. And right now we rely on apps sort of saying like, well, you're only allowed to see this thing, so we're only going to show you this. But like, the client should be dumb, right? The front end should just say like, hey, I got this blob of data. I'm going to show you this blob of data. And as long as that blob of data doesn't have PII or anything you shouldn't see, like, it would be great. So that's sort of like longer term, like that's down the line. Oh, sorry.
So, with regards to your front end, with your end user portal, what is your method of delivery there? Is it a container or it's a collaboration of microservices that are just pulling in from one big repository?
The front end, like the front end specifically?
Yeah, like the end user portal.
Well, so there's actually a few different front ends, right? So like we have an iOS app, we have an Android app, we have a web app.
The web dashboard.
Sure. Yeah, so it's a React app, pulling in data from these services, right? It's making like HTTP JSON calls, getting data. We're building like sort of stitching services. So like if you only care about like an org chart, that's not really like, you know, like you can have a service that will stitch together an org chart from these fundamental services that know what a company is, what an organizational unit is, what an employee is.
I guess what I'm asking is when you spin up a new client portal, right? When you spin up a new client,
yes,
right, in the system, are you spinning up a containerized environment, or are you spinning up a new accessor to different microservice?
Yeah, sorry. It's multi-tenant, so everyone's in the same set of databases, right? And the idea is that it's just now our permissions are built on top of that. But it's nothing new. Like a new client can come on board with no infrastructure change required.
So you use a lot of tools here, and you really eliminate a lot of common pain points. But you know, there's like 10 some odd tools you're using, and mushing them all together, or sorry, elegantly using all of them as they're appropriately used. Have they caused any new pain points?
Oh yeah. Oh yeah. Yeah, I mean, like a lot of this stuff, like we have been like, especially with Istio, right? And Istio is like amazingly neat technology. It's early, and they have backwards and compatible changes, and they're you know own up to that. There's bugs, like there are like very like easy to run into bugs that still happen. So lots of pain points. Spinnaker wasn't easy. Like none of this stuff was free. Like it was not, like meaning like not download a script, run it. Okay, cool. We've got this amazing development environment. And a lot of what we've done too is build tooling on top of it, right? Like so, configuring Spinnaker's hard. I mean, in that you have to click through UIs, or they have this crazy JSON blob. So we built tooling to sort of trim that down, simplify it. And so like it's been a big investment. But we're sort of at the scale where we have 100 engineers, right? And so if we have a team of 2 or 3 people who are just like knocking these things out one by one, that's like 3% of our workforce, making the other one, even if you make everyone else 5% more productive, right? Like that is a return on investment already. And if you make people like twice or 3 times as productive, like that's amazing, right? But yeah, no, like it's hard, a lot of early software, a lot of weird bugs, a lot of like, especially with Istio, like we're being very, very cautious. It's taken us a quarter to roll it out. We're doing it one step at a time, one company at a time, right? Making sure that it's very deliberate.
Any more questions?
Hi, thanks for the talk. I have a couple of questions. The first one is, why did you guys decide to go with gRPC instead of just like straight up REST API or HTTP API with things like Swagger where you can actually generate the same sort of things like you mentioned? And then the second question is, the workflow, the development workflow is really interesting where you can divert to your local development environment, but is there an option for the developer to actually visit the production environment? Because sometimes it's useful to do some compare and contrast between the 2 different environments.
So we, in part because of PII concern, we've really locked down the production environment. Because what if, if you give, say, a developer access to the SQL database, like someone could run a select star and get everyone's social security numbers. Like someone who's malicious could do that, someone who accidental could do that, So part of the nature of it has been that we've sort of locked down prod from a developer point of view. But there's no reason these tools couldn't run in production or staging as well. Does that answer your question, or does that? And now for Swagger, so the other part was gRPC, right? So one of the nice things, gRPC Gateway actually, it gives you Swagger definitions for free. So part of your I forgot about that. Part of your compilation is you get the swagger.json file, which is super nice. The reason we went with gRPC is in particular like schema evolution. So one of the, and JSON has their JSON schema is another choice. I mean, part of it is because I've worked with protobufs and gRPC for quite a long time, and so I'm very comfortable with it. And I think a lot of people at Namely are also sort of in that boat of it's comfortable, it's powerful. But schema evolution is a hard thing, right? I want to add a new field to my API. You want to know, like, what is my API? I want to be able to add that new field without breaking you. And so it gives you sort of a little bit more structure around that. But JSON is a tool. Like, it's not like this wouldn't work with if you decided to go with JSON.
Okay. Yeah, no, my second question about Istio is the fact that when I was watching, I understood that the diversion of the to local development is happening in prod as well. Is that not right? Or
no, but that's not that's a deliberate choice. That's not like a technological limitation. So right now, the tooling only knows how to talk to the integration environment. Like developers don't have the access credentials to talk to the prod environment like that.
Then does Istio give you a way? I mean, you write a wrapper to divert that traffic. Is there another switch so that you can, say I want to divert on demand so that I don't have to always be stuck with one flow versus the other?
Oh yeah. So the way that all these routing rules are Kubernetes custom resource definitions. So you can apply these anywhere. And this is actually like 2 layers down, right? So there were 3 layers down really where. So there's Istio, and then there is Telepresence like sitting on top of Istio as this extra tool that DataWire released. And then on top of that is this tooling that we built that wraps Telepresence, right? And that includes a service that's running in our cluster. That includes like an opinionated rules about like installing these routing rules. But there's no reason, like it's just sort of the development flow we've come up with. But like Istio doesn't limit us, Ambassador doesn't, or Telepresence doesn't limit us. Like so you sort of have that optionality. But again, it's the PII, right? You don't want someone running something on their desktop and suddenly, like even accidentally, like imagine you run a script on your laptop totally innocently. You're working on the accounts service, and for whatever reason, you're intercepting passwords as they come in, and you're logging this to your laptop. Okay, you forget about it. You forget you got this file. 6 months later, you lose your laptop. Someone's got a list of plain text passwords because like you've caught them on ingress, right? We don't want to do that. Or like social security numbers, right? Like this is the sort of stuff that we want to be very, very careful about because it's people's lives, right? And so we want to be very sort of responsible for that side of the business. But that's maybe other companies aren't. Like don't have that sort of data, or have other ways around that.
Great, thanks.
Of course.
All right. Yeah, Istio has a bunch of interesting intelligent routing options, like you can specify routing rules for users and IP ranges, all kinds of really cool, powerful stuff. It's impressive that you guys are, I think you're the first company that I come in contact with that's using it in production.
We spent like hours just refreshing the GitHub releases page, like waiting for that 0.1 release to fix some bug that we ran into.
Thank you so much.
And we'll be around later.
Martin,
if you want
yes,
to
if
chat.
you want to. Next up, we have Adhita from Stonybrook University. They're doing some research on learning algorithms and improving them for Kubernetes. And so he's going to be talking to us a little bit about Kubeflow tonight. Everybody want like a couple minutes, bathroom, stretch legs? Yeah? All right, let's take like 2 minutes. We'll get them set up and we'll reset.
Hi. Martin. Toby.
Nice to meet you, Toby.
I just realized we followed each other on Twitter. Anyway, so I was slightly confused about how Istio is different from the I guess, the prod environment or whatever.
I can show you. Yeah, so we have. Here come.
Because I was just thinking on one hand, I was like, aren't you saying, I was part of the question is like, are you saying that essentially there's like not really a separation between OS versus laptop? I mean, we're just
But the way it works is
Oh, yeah, well, is there any projects? Yeah. Thank you.
Do you know anybody else playing around with Istio production?
Few people outside campus to see. I want to play around for that.
Yeah.
Yeah, answer my question.
And then so when you get those parts, it says, hey, go to this, go to the lab, go to the other end of the lab. And then when that presents something, so it's not like actively drop it. It's an open source tool. And then we just built some tooling. And then the idea is, just lets us say, we want to say, if you create a question here, right? We actually want to send to a laptop. So this thing thinks it's on the feed, it's actually on the feed. And this thing that sends it to C, and it actually gets on the last back on the cluster. So yeah, these guys are really good. And Richard, you guys started this, is really helpful. Yeah. Oh, he's told me that. I'll send him like a connections tool and send him like that 3 days thing. Oh, fun.
That's nice.
What are you doing?
Must not sleep.
You're a young startup.
Yeah.
This is a forward.
I'll probably try this.
Anything that you move emails on the invite. Wait, not as smart as that.
Spinnaker is tailored a lot more to one of the things it does is by default is deploy an entirely new version of your service, make sure that it is not all health checks, and then it can cut traffic over from the old so you have to scroll a lot of that.
You mean like rolling back or things like that?
So yeah, so by default, Kubernetes, it does a rolling deployment. So it currently is adding new pods to your set. If you're at 5, it'll upgrade to 1.1. So if you have a problem, you don't have to know you're entirely whereas with Spinnaker, when it's it'll bring up your older new version, let you test the new version. But it's been a lot of independence and and then you can slowly cut that over if you wanted to, cut it over, and it'll keep the older new version up. Maybe the new one is all traffic and the old one is there for some time window before it's
So it's just a simultaneous kind of checking, testing.
Yeah, exactly. It's built into the
Spinnaker does it.
yeah, and you can get fancy with CI/CD if you were doing your own kind of Kubernetes service. Writing those
And I think maybe 4 years ago, it's worth looking at. Great product, I loved it. Oh, okay. So then it's Payroll. I'm pretty sure. So we used to do everything Payroll. Now it's cloud. You just sort of left Payroll. So you probably really, I think I've seen very interesting stuff. Really, so I'm looking forward to talking. We're dealing with concepts of that ever since. Transaction across Rails. Oh, good. And it's sort of like, it's going to be fine. Don't worry. It's not, yeah, but I mean, look into this. We haven't run this thing yet. I'm Bill Kelsey. I have a over at sea. Absolutely. I noticed that there's stuff going on. Okay, well, I don't want to joke. So AWS, we're sort of keeping up with we're using Kubernetes, but yeah, we're going to launch that with Istio, Humbug, and Payroll. No, it's been talking about those, and then moving more to very hot.
All right. Go ahead and start working your way to the seats. We'll go through this talk. Should be around 15 minutes. 10, 15 with some questions, hopefully, and then we can all go back for mingling. Thank you.
Hello. Hi everyone. Today I'm going to be talking about machine learning on Kubernetes and a little bit about Kubeflow. And a little bit about myself. I'm Adhita Selvaraj. I'm doing my master's in electrical engineering at Stonybrook University. My research focuses on optimizing training times of deep learning jobs on Kubernetes clusters. And we're also focusing on improving resource utilization on Kubernetes clusters. I'm contributing to the Kubeflow project currently. And I created this project called DL Corps, which makes it easy to get started with machine learning on Kubernetes. It lets you, say you have a bunch of SSHable machines, it lets you install Kubernetes, install NVIDIA drivers on it, and get started with machine learning on that. So moving on to why Kubernetes is great for ML. And so OpenAI recently scaled their cluster to around 2,500 nodes, and they were able to run their complex machine learning workloads and everything on Kubernetes. And so this is the maximum scale at which you can operate with Kubernetes and extend your machine learning problems on Kubernetes. And yeah, so this is what is offered. And regarding our journey from starting out with Kubernetes, initially we wanted to, we had this algorithm for optimizing training times, and we were looking at orchestrators and schedulers like Mesos, Spark, and Yarn, and we chose Kubernetes because at that time GPU support was better compared to the other platforms, and the community in general was quite responsive, and so that's why we chose Kubernetes. And initially we had a lot of trouble setting up Kubernetes on our cluster and enabling feature gates because it's in experimental support and it's not mainstream yet. So we had to go through a lot of manual steps to install Kubernetes and sort of install NVIDIA drivers, and getting your GPU to be exposed inside your container in itself is a big problem, and it involves a lot of manual steps, so it's kind of tricky. So and then we started work on the scheduler, and I hadn't learned Go initially, so learning that and setting up that was kind of hard initially to get started with. And we are using Chameleon Cloud. We couldn't afford any GCP or AWS, so we using Chameleon Cloud, which is free for academia. So if you have if your project is funded by the NSF, they give you free nodes, like they give you NVIDIA P100s and K80 GPUs. So that is pretty cool of them. And so initially when I started out with learning how the scheduler works and everything, it is quite hard, and you don't know where to look for initially, and you're sort of at lost to see, kind of figuring out how the scheduling logic works and everything. So people on Slack helped out a lot, and they kind of you slowly work towards you first look at the kube scheduler logic, and then you kind of look at the preemption and the predicates, and slowly you start to figure out things, and that's how we started out. And regarding Kubeflow and what Kubeflow is, it is an ML toolkit on top of Kubernetes. It aims to abstract away infrastructure from data science. So say you have a Docker container and you have your machine learning workload inside it, and you don't have to worry about scheduling, and you don't have to worry about all the infrastructure part of data science. You just have to give the Docker container and the resources that you want for that particular job, and Kubeflow will take care of scheduling your workload onto your cluster and things like that. And it aims to be portable, as in you can have the same set of workflow for your local laptop and for your public cloud, and say you're running your workload on GCP or on AWS. It aims to have a uniform workflow wherein you have the same set of repeatable steps for your laptop as well as on GCP. So we do that using Quesonet. So you have repeatable deployments which are done through Quesonet, and so in this way you can have quick iterations wherein you can work on your laptop, and you can repeat on your you can experiment with the Jupyter Hub and Jupyter Notebooks, and you can Dockerize that code and then eventually schedule it on your cloud cluster without any change in the workflow that you have. And these are some of the alternative projects that are working with machine learning on Kubernetes. DL Workspace is a pretty mature project, but then in DL Workspace you'll have to make slight modifications to the core of Kubernetes, and installation process in itself is kind of a bit harder. And regarding kubegpu, kubegpu is the scheduling part of DL Workspace, and things like so suppose you have a GPU cluster and you have a set of GPU nodes connected through NVLink or any such interfacing. You can kubegpu takes into consideration the topology of the nodes and adds that into their scheduling constraints so that you can have a faster training process. And also RiseML and Pachyderm or other projects that are working with ML on Kubernetes. And why do we need something like this? Because right now it's very hard to get started out with machine learning on Kubernetes, and you need to go through a lot of manual steps to configure your system before you can start doing submitting training jobs on Kubernetes. So if you can have a repeatable workflow that is quite simple, you can start out with your laptop and reproduce it across all clouds. And so what do you have in Kubeflow? The core components are a Jupyter Hub. So you can experiment with your model on Jupyter, and then you have a template for TF jobs. So the input is your Docker image and the set of resources that you want for that particular job. So say you want 2 CPUs and 2 GPUs for that particular job. You just give the name of the Docker image and the resources, and Kubeflow will automatically schedule that job onto your Kubernetes cluster. You don't have to worry about anything else regarding the driver management and mounting those particular drivers onto your container and all that. You have a TF job dashboard wherein you can you have a job dashboard which is similar to this, wherein you have you just have the image name and the resources that you want. You can input that and you can schedule the job directly. And you have TensorBoard through which you can monitor your training process. And this is the Argo workflow and UI dashboard are a work in progress, wherein you can so when you're working on your code on Jupyter Hub, you can Dockerize that particular code and you can deploy it to production, or you can make a model out of it and you can have an inference job run from that. So Argo makes all those easier, and you have a centralized dashboard that connects all these UI services. So we're using Datawise Ambassador to connect all these services. So Jupyter Hub, TF Job, and the TensorBoard are all separate services, and we're using Ambassador to reverse proxy all the services and bring it under one central dashboard. And the TF operator, what it does is, right now in vanilla Kubernetes, you have to install NVIDIA drivers manually, and you'll have to mount them onto the container through volume mounts. The TF operator abstracts away all those driver versioning and everything, so that you just have to give the you don't have to worry about the driver versions and all that. And Selden is also incorporated into Kubeflow right out of the box. And so this is the eventual place that we want to be, wherein you have a centralized dashboard, wherein you can set up your Kubernetes cluster and you can bootstrap it. In the initial step, you can install NVIDIA drivers and everything, and then you have a job dashboard wherein you can submit your jobs, and you have a Jupyter Hub wherein you can experiment with your models and you can build out your model. And then you have a Grafana dashboard which could take in import metrics through Prometheus, and you can watch metrics like your GPU resource utilization and stuff like that. So in the end, you just want repeatable deployments that are say you're working on your laptop and you want to kind of have that same workflow repeatable across your public cloud and everything. And yeah, that's pretty much it for Kubeflow.
Questions? Yeah. By the way, KSonnet, Heptio project, Ambassador is another DataWire project.
DataWire is awesome.
Okay, two things. First of all, just a little observation. Putting Elon Musk's head on a SLS rocket would be like basically having Steve Jobs present an Android phone or having Steve Jobs use a Windows computer. Sorry, but I was an aerospace engineer, so I know these rivalries. And now the question: how exactly does your system deal with more niche aspects of machine learning, like say genetic algorithms or fuzzy logic or graph theory? Does it?
Right now it doesn't deal with all that. So the scheduling part of Kubernetes is still the same, and yeah, so right now it's not that mature yet.
Thank you.
Other questions?
So where do you see the use cases primarily for combining Kubernetes with machine learning?
Regarding that, I think the scale at which Kubernetes offers you. So suppose you have an ImageNet data set which is 500 GB. So if you want to train your model on that, you're going to take like 4 days on your local cluster. So if you scale that out on Kubernetes, you can do it under 10 hours, 4 hours, depending upon the size of your cluster. So that is where Kubernetes comes in and kind of, so you can iterate faster on your models, and you can experiment with more number of models, and you can, so in Kubeflow, you can, suppose you train your model and you can run an inference job on that model, and you can test out your model, and if you see that it's not as accurate as you expected to, then you can retrain your model. You can go on Jupyter and you can tweak your parameters such that your model is better, and then you can retrain it again, and this time maybe scale it out to a larger number of nodes so that you can get your results faster, and then put an inference job on that and see how it plays out. And so you have faster iteration cycles, and so that's where Kubernetes comes.
Very good.
So Kubeflow, obviously very integrated with TensorFlow. Is TensorFlow serving somehow integrated in this mix?
Right now they have inference job containers, as in they give you a template which does inference on that. So in the future maybe it will be included as separate. And Kubeflow is not specific to TensorFlow. Right now it might seem so, but in the future it has plans to support PyTorch and other platforms as well. So yeah, right now it's just TensorFlow, but in the future it will be supporting all other frameworks as well.
Nice. All right. Good. All right. thank you all so much for coming out on this Tuesday evening. I hope to see you next month. We have the space for a little bit, so feel free to mingle. Again, Sysdig, Tarek in the back, Oracle meetup over here, and if you're, I think Danny took off, BounceX hiring. Oh, no worries.